Hey AP students, I am back with All About Motion Part 2. Before you watch this video, make sure that you go back and watch Part 1 because I'm going to dive right back into where I was. Today we're going to go over the kinematic equations and my foolproof way of understanding them. Then we're going to get into horizontal motion and vertical motion. We're just dealing with one dimension right now. Once we master 1D, we'll go into 2D. Let's get started. Now, most of the time I say everything's on the equation sheet. I may have lied. There are a few equations that you need to memorize because College Board does not give them to you. However, as a good physics student, you should already have them memorized. First of all, we have our average speed equation. This is not given to you, but very important. Speed is distance over time. The second one is our velocity. So that's our change in distance over time, aka our displacement. Have that memorized too. And finally, let's memorize our acceleration equation. Now, technically speaking, our acceleration equation is on our equation sheet, but it's better to do it this way. So acceleration is change in velocity over time, VF minus velocity initial. Take a moment, memorize those, write them down a million times. You are going to need to have those memorized for the AP test and also the class. Let's get started on one of the most important set of equations on your equation sheet. These are our three kinematic equations. Please look in your equation sheet and pause this video to find these three. Okay, cool, you found them. These three equations are going to guide us throughout. A couple things that I want to note on here. You'll see that all throughout there's this X situation here. This is to show that it's in one dimension. This could change from X to Y. When I write things out though, I am not going to include that for our sanity. You are going to notice that there's a lot of stuff in here. I'm going to break it down as easy as possible. Let's get started. You'll see there's V. This is equal to V final. You will also see that we have VO. Now, personally, I write this VI. Depends on your physics teacher. This is V initial or our starting velocity. Everything has a starting velocity. If you're not sure what it is, it's probably 0. Now we have this weird situation with X and X0. But frankly, I don't write it that way. I write it as delta X. Delta X is equal to our displacement. Now, this is how I kind of change up these equations. I personally get rid of this. Whoops. I get rid of this and I put delta X equals. I get rid of this and I put delta X. Trust me, it'll make your life a million times easier. What do we have left here? We have A, acceleration, and we have T for time. Now, many students look at these equations and panic because we're like, there's all these variables, I don't know what to do. We are going to be using these equations in word problems and real-life situations, and we are going to need to figure out which one to use. We are going to use the yes or no method, and we are going to go back to this a little bit when we start doing problems. In my yes column, I'm going to go through everything that's in this first equation. Is there V final? Yes. Is there VO, V initial? Yes. Is there displacement? Nope. Is there A? Yes. Is there TS? Yes. Now, this is telling me that if I am looking for displacement or have displacement in the problem, I cannot use this equation. Let's go on to the next one. Do I have V final? No, I do not have V final. I'll write this over here. Do I have VI? Yes, I do. Do I have A? Yes, I do. Do I have T? Yes. Do I have delta X? Yes, I do. Last problem. Do I have VF? Yes, I do. Do I have VI? Yes. Do I have T? Nope, I don't. Do I have A? Yes, I do. And do I have delta X? Yes, I do. This chart will save your life. Every time you are working on kinematic problems, you need to have this out. You'll notice in each of these that VI is in every single one. You'll notice in some of our equations as well, there's not an equation without a. Okay, so you may need to use your memorized equations for this. Let's dive in and use this wonderful chart. We are getting into 1D motion horizontal. This is anytime something is moving only in the x direction. So let's say I'm walking. I'm going to have a VI. I'll have a V final somewhere. I'll have A. I'll have T. I'll have delta X. Now, it's not necessarily going to mean that they're in every problem, but that exists in every single 1D motion problem. Let's see what this would look like in a word problem. Let's get started with our first problem. A ball with a starting velocity of 2 meters per second rolls across the table 2.8 meters long to a stop. What is the acceleration in the time? Let's write down all our variables. I know my initial velocity is 2 meters per second. Note how I'm adding in my units. My displacement is 2.8 meters. It says it's rolling to a stop. That means my final velocity is 0. And I am looking for acceleration and time. What I need to do first is figure out what equation I need to use, okay? I have my VI, VF, delta X, and A. I don't have time yet, so I need to find an equation without time. Take a moment to look at your chart to figure out which one that is. That is my third equation. So I have VF squared equals VI squared plus 2A delta X. We are sophisticated physics students, so we need to solve for A. You are required to rearrange. A couple of reasons why A, it shows your deeper understanding, and sometimes you'll have no numbers to plug in. I'm going to subtract VI squared from both sides. And then I am going to divide by 2 delta X. Why can I do that? Well, order of operations. Okay. Then at this point, I can plug in my numbers and solve for A. Remember, my VF is first, then 2 meters per second. That whole thing is squared, and that is over my 2 and delta X 2.8. For my answer, I'm going to get negative 0.71 meters per second squared. Meters per second squared is my unit for acceleration. The second part of this problem is to solve for time. Now at this point, I could really use any equation I want to, but I am lazy, so I'm going to use the easiest equation, which is the first one. So VF equals VI plus AT. I'm going to solve for T. Take a moment to rearrange yourself. I'm going to get VF minus V1 over A equals T. From there, I can plug in VF is 0 minus 2 over my acceleration I just found, which you'll notice is negative, and this is going to be really important to us. I get 2.8 seconds. Why is this so important? My negatives cancel out. I cannot have a negative time. That makes no sense. This is how I solve for this problem. Great job. Let's move on to vertical. Now let's look at 1D vertical motion. Same equations, but now we are only moving in the vertical direction. Now what's cool about these problems is we already have a given every single time. My acceleration is always equal to gravity every single time. What is gravity? Negative 9.8 meters per second squared. Okay. Why is it negative? Well, gravity is always pulling us down. What else is going on in these problems? Well, I could have a multitude of things happening. I could have something dropping. I could have something being thrown up in the air. But I still have a time, velocity final, velocity initial, and delta X. Let's just dive in and try a problem. we are going to get started with a problem for this. This is kind of our basic problem. In class, we're going to get a lot more in depth with some more difficult problems. We're just going to start it off pretty simple right now. A ball is dropped from a height of 100 meters. What is the time it takes to hit the ground and the final velocity? Let's think about what we know. I have this ball and I am just dropping it and it's going down and then it hits the ground. What do I know first in every single problem? Vertical, my acceleration is negative 9.8 meters per second squared. Next, my delta x, let's think about this. This thing is going downwards, which means I need to have a negative displacement. Very important, because if I don't have this, it's going to mess up my whole problem. And then what's my initial velocity? It's 0. I am looking for time and final velocity. Let's look and find an equation without final velocity. That's my second equation. Delta x equals VIT plus 1/2 AT squared. I can get started by getting rid of VI because it is equal to 0. Anything times 0 is 0. Don't forget that. I am a sophisticated physics student, so I am going to solve for T. I will write out the work for this problem. And then we'll get started. And I'll talk about why it is super important that we properly write down our delta x. We are going to plug in our numbers right now and talk about why it is so important that I wrote down my displacement as negative. If we think about math, I cannot have a negative under a square root. That is an illegal math move. And if I did, something would be wrong, okay? So I'm gonna get my time as 20.4 seconds to hit the ground. My second part asked about velocity final. I could technically use the first or third equation, but I am lazy, so I am going to use my first one because it is the most simple, okay? This is actually the acceleration equation that you had to memorize, but it's nice to have it memorized in two forms. I can get rid of my V initial because it's 0, and then I have VF equals AT. I can plug in for there, make sure I am including my negatives and my units because we are sophisticated physics students, and it frankly just looks way better and is easier for your teacher to check. I'm going to get negative 200 meters per second. Wow, that thing's moving fast. Why is this negative? Because when it's hitting the ground, it is going downwards. Remember, velocity is a vector, okay? If it asks for the speed when it hits the ground, that would just be 200 meters per second. Move. Here are a couple more practice problems for you to do. I'm not going to solve them in this video, but they are something that you probably just want to do on your own. Here is our horizontal problem. Pause it. Take some time to figure it out. Here is our vertical motion problem. We didn't go over this whole throwing something up and then it coming back down, but I would take a little bit of time to just draw it out and write down your variables.